In this video, we look at the API gateway, a foundational mechanism that sits at the edge of a distributed system and acts as the single entry point for all incoming requests. By the end, you will understand what it does, why it exists, and exactly when you should and should not reach for it. Imagine your system has grown into a set of separate backend services, one for users, one for orders, one for payments. Every client now needs to know where each service lives, handle its own authentication, and deal with failures independently. Anytime you rename, move, or split a service, every client breaks. Cross-cutting concerns like security and rate limiting get duplicated everywhere. The system becomes fragile and very hard to change. Think of a large hotel. Guests never wander into the kitchen or knock on the housekeeping supply room. They go to the front desk. The front desk verifies who you are, figures out which department handles your request, forwards it, and brings back the answer. The API gateway plays exactly that role for your software system, one known location that handles every incoming request and shields the internal layout from the outside world. Here is the structure. Every client, whether a browser, a mobile app, or an external partner, sends its request to one place, the API gateway. The gateway sits in front of all your backend services and is the only thing clients ever see. Behind it, your services can move, split, or be replaced without the clients noticing. The gateway owns three core jobs: verifying identity, enforcing limits, and routing each request to the correct service. Follow a single request. The client calls one well-known address, the gateway. The gateway first authenticates the caller by checking a token or API key. It then applies a rate limit, rejecting the request early if the caller has exceeded their quota. If both checks pass, the gateway inspects the path and method and routes the request to the right backend service. The service processes and replies to the gateway, which then sends a clean, unified response back to the client. The client never learned which service it actually spoke to. The gateway is a powerful pattern, but it carries real costs. On the benefit side, you get a single enforcement point for security and policy, clean decoupling between clients and services, and a natural place to add observability. On the cost side, every request now travels through one extra component. If that component is slow, every client feels it. If it crashes and you have no redundancy, your entire system goes down. For a small monolith, or a system with only two services, a gateway is almost certainly more complexity than it is worth. When should you add a gateway? A useful rule of thumb is 3 or more independent backend services. At that point, the duplication of cross-cutting concerns starts to hurt. Once you add one, run at least 2 instances behind a load balancer, so the gateway itself is not a fragile single point of failure. Resist the temptation to put business logic in the gateway. Keep it thin. Use it for routing, authentication, rate limiting, and response shaping. Watch its latency and error rates closely, because every client in your system flows through it. To summarize, an API gateway gives every client one well-known front door and keeps your internal services hidden behind it. It is the right place to centralize authentication, rate limiting, and aggregation, so those concerns do not scatter across every service. Because of that central role, resilience is non-negotiable. A gateway that goes down takes the whole system with it. Scale it horizontally and monitor it as carefully as any critical service.